Section 10.5. Now we're switching to the lengths of the segments in the circles, not the angles. We just did all the angle relationships. Okay? All right. So when you have two chords, so chords intersect your circle in two places, and they intersect on the interior, each chord is divided into two segments called segments of chords. Okay? So again, 3 theorems from this section, okay, deal with the segments. So it says, first one says if you have two chords on the interior, so that's inside, then the product of the lengths of the segments of one is equal to the product of the lengths of the segments of the other. Okay, so your circle. Here's one chord, here's a second chord. We have chord A, B, and chord C, D. They intersect at point E. Okay? The segments, so segment AE and EB, that's from one chord. So AE times BE has to equal this. Segment here times this segment here. So CE times DE. That is for two chords that intersect inside your circle. Okay? Then you can have a tangent, okay? So we have to go over some definitions first. So, given a circle, if you have a tangent, okay, it's called a tangent segment. It's just the piece that goes from the tangent, has an endpoint on the circle, okay, and then it extends. So we would say that PS is a tangent segment, okay, because it has an endpoint on the circle. And then you can have a secant and a secant segment, okay? So secant would be like PR, right? It passes through the circle, touching it in two places. The secant segment has endpoints on the circle, and it's secant to the circle. PS is a tangent segment. And then when you have a secant segment, you have an external secant segment, which is the part outside. Okay, so here PQ would be your external secant segment. It's the piece that's on the outside of the circle that is secant, or the piece of the secant that is on the outside of the circle. Okay, it's a external secant segment. So then our theorems for those, okay? Go with the secant and the tangent. So 1016 tells us that if you have two secant segments and they share an endpoint outside the circle, then the product, so you're multiplying, of the length of one secant, so the entire secant, and its external, equals the product of the other secant and its external. Here's our circle, okay, our two secant segments. They're intersecting out here at point E. So this is secant EB or E, yeah, it's drawn wrong in your notes, okay? Switch this, you look at your notes, switch this to a D. It should not be B. Can't have both of them be point B. So we're gonna say it's ED, okay? And then the second point would be at point A here and a point C here, okay? So the entire secant is EB times its external, which is EA, is going to equal the entire secant here, so ED, times its external, which is EC. Not just the part inside the circle. It has to be the entire secant, okay? The length of the whole segment. And then theorem 1017, okay? Talking about a secant and a tangent. And they share an endpoint outside. Then the product of the length of the secant and its external is going to equal the square of the tangent. Okay, so if we look at that, here's our circle. Here's a secant segment and a tangent segment. The secant is ED and the tangent is EA. The secant has our second point here to create your external. So it says the whole secant, which is ED, times the external, which is EC, equals the square of the tangent. So the tangent is EA, and we square it. Let's talk about the lengths of the segments. Okay, so now we can do some problems with numbers. Those are our theorems. Okay, so here is a circle, right? Here's one chord. Here's another chord. This is chord B, A, and C, D. CD is divided, so this length is 12 and this length is 9. BA is divided, so this is X and this is 18. We want to find X. So it says for chords that the product of the segments is equal to each other. So this tells us that this is, we don't know what that point is, okay? So this would be 18 times X, because that's the part of segment AB, or chord AB, is equal to the product of the parts of CD, so 12 times 9. So then solve for X. 12 times 9 is 108. Divide both by 18, and X is 6. So the length of this segment right here would be 6. We have another circle, okay? And we have two secants. They're intersecting outside at point D. So this is F, E, and HG. We are told that EF is 10 and ED is 11. HG is X and GD is 12, okay? So what it tells us is that the entire secant, so this whole secant is DF times the external, which is DE, equals the whole secant, so DH, times the external, which is DG. Okay, so the length of DF is 10 plus 11. You need this entire length times the external, which is 11. The whole length here is X plus 12 times the external is 12. So this would be 21 times 11 equals 12X plus 144, because we're distributing the 12. So 21 times 11 is 231 equals 12X plus 144. So we're going to subtract 144 from both sides. So 87 equals 12x, and divide by 12. And we get x is 7.25, or 7¼ okay? So when it's 2 secants, it's the whole thing times the external equals the whole thing times the external. All right, last one. You have a circle with a tangent intersecting at point B and a secant. They intersect at point A, and our secant is D and C. The length of our tangent is 30. The external part of our secant is x, and the internal part is 24. Okay, so the theorem tells us that the length of the secant, so AD, times its external, which is AC, is going to equal the square of the tangent. So the tangent is BA, and we'll square it. So AD is x plus 24 times the external piece, which is x. BA is 30 squared. Okay, then we have to solve for x. So we're going to distribute the x. We get x squared plus 24. X equals 30 squared, which is 900. This becomes a quadratic. So we're going to have to put everything on one side and then factor. Or you can use a quadratic equation. So x squared plus 24x minus 900 equals 0. Don't really want to have to try to find all the factors of 900. So we'll use the quadratic, okay? Quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is from algebra. You should know it. You should know how to use it, okay? I'm just going to plug in my numbers because, again, this is review. You learned it in Algebra 1. So we'll put it up here. X equals negative 24 plus or minus 24 squared minus 4 times 1 times negative 900 all over 2 times 1. Simplifying, so negative 24 plus or minus 24 squared plus 3600 divided by 2. This is in your notes. I'm just erasing a little bit of it. Then we get negative 24 plus or minus the square root of 4,176 divided by 2. This is not a perfect square, so you get a decimal. So I'm going to round it to here. Okay, so 64.6. Then you have to remember to split it up so you could potentially get 2 answers. So negative 24 plus 64.6 divided by 2, or negative 24 minus 64.6 divided by 2. For our problem, x is a measurement, okay? It's the length of a segment. This answer here will give you a negative number, so we don't really even care exactly what it is because it won't apply because distance can't be negative. So here, we're going to get negative 24 plus 64.6, and then divide by 2, we get 20.3 for your value for x, because it's a distance, so it can't be negative. And that is 10.5.